This is section 7.2 notes. Today we're going to talk about when we can actually add exponents together. In order to add exponents together, their base numbers, or the big numbers that they are attached to, have to be identical. So for example, if you have 12 to the fourth times 12 to the third, the 12s, the bases, are identical. So I can actually rewrite this as 12 to the 4 plus 3 because I'm able to add my exponents together. Now, when I add those together, I get 12 to the 7th power, because 4 plus 3 is 7, and then I can plug that into the calculator pretty easily and get an actual number out. So this is 35,831,808. So that would be my final answer. I actually end up not having any exponents in my final answer. It works the same way when the base numbers are both in parentheses, as long as they are still identical. So -5 in parentheses to the -2nd power times -5 in parentheses to the 7th power. Now I have to keep my identical bases the same, so I have to keep them in parentheses, and then I can add the exponent, so -2 plus 7. So -2 plus 7 is going to give me a positive 5. So I have in parentheses -5 to the positive 5th, and then I go ahead and plug that into my calculator, and I get -3,125 as my final answer. Next, I have both numbers and letters. So I have 4z to the 5th times 9z to the -12th. Now, if you notice, the exponents are just on the z's. Okay, so I get to isolate those and add them together. But what do I do with these big numbers? So 9 and 4. Well, the operation that's going on in between them is multiplication. So I'm going to go ahead and multiply those two numbers together before I even get to the z's. So 9 times 4 is going to be 36. Then I work with the z's. So z to the 5th, and z is the same base with the -12, so I get to add 5 plus -12. And that gives me z to the -7th. Now I'm able to put this together. So I kind of took it apart and now I get to put it back together. So this is 36z to the -7th. Now, from what we did yesterday, am I allowed to have a negative exponent? No. So I'm going to do what I did yesterday and circle it and move it down in the fraction. So the 36 gets to stay, but z has to move to the bottom in order to make this -7 a positive 7. So my final answer actually ends up being 36 over z to the positive 7th power. Okay, taking that idea and getting a little bit more complicated, we're going down to problem 2. So here we have 2a to the 2nd times 9a b to the -4th times -3a to the 4th b. Whew, that's a lot. So I'm going to take this a little bit at a time. The first thing I'm going to do, because all three numbers are different, I'm going to go ahead and multiply them together. So I'll have 2 times 9 times -3, which ends up being -54. Then I'll have to deal with the a's. So the one has an exponent of 2. The next one doesn't actually have an exponent, it's invisible. The only number that's allowed to be really invisible in these problems is a 1. So this is really a to the 1st power. So I'm going to do 2 plus 1 plus this last one has an exponent of 4. So I keep the a as the base. 2 plus 1 is 3 plus 4 is 7. So this becomes a to the 7th. Then I go to the b's. So this first one doesn't have any b's, so that's 0. Plus this middle one has a -4, plus this last one has a b but doesn't have an exponent. Remember, it's invisible, so that's a 1. So 0 plus -4 plus 1 gives me b to the -3rd. So I did each part separately, broke it down. Now I put it back together as one problem. So this is going to be -54, a to the 7th, b to the -3rd. Now, I'm going to ask you again, can you have a negative exponent? Your answer is no. So I have to move the b that has the -3. So these two, the -54 and the a to the 7th, get to stay on the top of the fraction. but I have to move the b down below in order to make it a positive 3. So that's my final answer, negative 54 a to the 7th divided by or over b to the 3rd. Okay, this next problem looks a lot more difficult because you have parentheses. However, it's the same exact thing as if you just wrote it out with multiplication. 2a to the 2/3 times 3 b to the 1/4 times a to the 1/3 times b, or 5b to the 1/2. That is the exact same thing. The parentheses are just showing that there's multiplication here. Okay, so you can rewrite it without parentheses if that helps you. We're going to go through the same exact steps. We're going to take the big numbers that are out front of each one of these and multiply them. So I have 2 times 3 times 5. So 2 times 3 times 5 is 30. Then I take the a exponents. So I have a, the first one has a 2/3, and I add them. The next one doesn't have any a's, so that's 0, plus 1/3, plus 0. So 2/3 plus 1/3 is actually 1. Now the b's, well, I don't have any in the first part. The second part is a 1/4. Third part doesn't have any, and the fourth part has a 1/2. So 1/4 plus 1/2 is 3/4. You can use your calculator to do that, or you can make them common denominators and add. So once I have all of these parts, I put them back together. So I get 30, a to the 1st, b to the 3/4. Now I don't have any negative exponents, so that will be my final answer.